So by the way, Shubha, you did not join the thermodynamics class if you remember, right?
Sir, I joined it, sir.
आपने join किया था?
Yes, sir.
अच्छा अच्छा हाँ ठीक ठीक ठीक. So I said that do thermodynamics in a different copy ना. आपसे शेयर
Yes,
करा था
sir.
हमने. अच्छा अच्छा ठीक है. तो लास्ट क्लास में थर्मोडायनेमिक्स में कहाँ तक पढ़ा था हम लोगों ने?
Just a second, sir. Sir, we did the thermodynamic processes, sir.
Till thermodynamics
Isothermal
1 2.
process, adiabatic process.
Right now, we are going to learn about the, what do we say? Some basic concepts, huh?
Yes, sir.
So, as I said, we are going to learn about solutions. We are going to look at different concentration terms. Just think about it. Okay. Solution. So basically, solution is what? It is a homogeneous mixture of two or more substances. Please write it with me. The homogeneous mixture. I hope you know the meaning of homogeneous. Uniformly mixed.
Yes, sir.
Huh? Homogeneous
Yes.
mixture of two or more substances. Two or more substances is called solution. So whenever we are going to mix something, there will be something which is known as solvent. There will be something which is known as solute. And generally, we are going to take a binary solution in class 11 as well as in 12. Sometimes we are going to, we are not going to ignore which is more than binary, but that is for sure. We are going to mostly talk about what binary solutions. We are going to mostly talk about binary solutions. So in this, if I have, let's suppose, water, and inside water, I have certain something added, something dissolved inside water. So in this, we have two components, and a solution with two components is known as binary. Now, binary solution, a solution with two or more components. My bad. With only two components, not more. With only two components. With only two components. A solvent. I will denote solvent as A. Solvent is generally present in major amount. Major amount का मतलब in larger amount.
Yes.
Then we have one solute represented as B. This is present in amount, minor means small amount. Na? Minor means small amount. In small amount, the solute will be present. Now, I hope you're writing with me. You're writing with me, Shifa?
Completed, sir.
Completed. Okay, thanks. Very good. So, whenever we talk about a solution, for example, even if I take chai, even though we drink chai and we can drink chai at different places, all the chai is not same. Now, what different? Maybe the amount of milk is different. Maybe the amount of tea leaves is different. Maybe the amount of sugar is different. So these things we make a term that is known as concentration terms, and each and every solution can be defined by its concentration. For example, if I have a salt water salt water may be same or may not be same depending on what amount of solute, that is salt, is added in the water. If I have more salt, then we say that it is more concentrated. If I have less, then we call it dilute. Now, if I specify how much salt is added in how much water, that tells us about a concentration term. So we are going to use different concentration terms. Please write concentration terms. Now, in concentration terms, what will they do? Gives an idea about the amount of solute in particular amount of solvent or solution. Okay. Now, the concentration term that we need to learn is known as mass percentage. We write topic number one, mass percentage. Basically, in mass percentage, I will give you a formula, but that formula is not very much useful. It is useful for very elementary type of questions. So, mass percentage is equal to the mass of solute divided by mass of solution, total mass of solution multiplied by 100. Keeping in mind that whatever mass you are going to use for solute, whatever unit you are going to use for solute, you will use the same unit for solution also. So this will be a pure number that will not contain any type of unit. It will be percentage, pure percentage. Now, formula is very elementary formula. But what is important, if mass percentage is given for a particular solution, then how we can use it? Please see, if let's suppose our example because let's say that for example I have 10 percentage, 10 percentage W by W. Either this is written or they say 10%. I mean, these square brackets is to separate these things. Square bracket नहीं रहेगा जब 10 percentage by mass of aqueous NaCl. Now, this is one of the most important thing that you are going to study in chemistry. That what are the stuff that you can extract from a particular line. Maximum number of stuff you have to extract. Whether it is useful or not useful, the first thing that you have to do is you have to extract as much information you can from a particular statement or particular line, from a particular word in chemistry. Chemistry के problems में you will be very limited information is given and you have multiple information from that particular line. Now यहाँ पे देखिए, as soon as you see that you have here aqueous, that means your solvent which represent as A is going to be what? Water. And the solute, that is B, is going to be what? NaCl. Now, what are the things that we can talk about water? What are the things that we can talk about NaCl? No matter what the concentration of the solution is, what is given. As soon as you have what? H2O, then you can tell me the molar mass of the solvent is 18 grams. You can tell me the molar mass of the solute. It is how much? I think it is what? 58, 35.5, and this is what? 23, na? So 58.5, right? So the molar mass of NaCl is 58.5. Now, are we going to look at percentage part? What does it mean? As soon as you see 10 percentage, then please remember the mass. If they have given you the mass of solute as 10 gram, percentage is 10 gram. The remaining amount, 10 in 100, right? So the remaining is water. So mass of water inside it is going to be 90 grams. So the total mass of solution will be equal to 100 grams. Does this make sense? Yes or no? Please tell me. ठीक है? So see, this is specific. For example, in this particular example, this is specific. Like in general, if I say X percentage W by W is given, or they have given X percentage by mass, then there are a few things that you can for sure write. Mass of solute will be equal to X gram. Mass of solvent will be equal to 100 minus X gram. And mass of solution will be this is what you can take and solve the problem. Now, it doesn't mean that it is always 100 gram, but if this is the limited information given, then these are the things that you can assume. Philip, let me know once you're
Yes.
done. If you have any doubt, yeah, Riza, tell me.
No, sir. Done, sir.
Done.
Yes, sir.
For example, calculate the mass NaCl present in 5 gram of 20% W by W aqueous NaCl. Okay. Now, please see in this type of question, you have to be a bit. This is easy question, but if you just start applying the formula, they will say, oh, any mass of NaCl, they will just look at 20% and they will write WB, it is equal to 20 grams. But is this tell me?
No, sir.
No, right? Mass of 20 gram is present in what? In 100 gram
500
of
grams.
solution. In
Yes.
100 gram of solution, it is present, right? Now,
Yes.
in 500 grams of solution, we can say the mass of NaCl will be equal to what? 5 into 20. That is equal to 100 grams. Make sense?
Yes, sir.
A very similar case is for volume percentage. As V by V. So the formula is similar to what the mass percentage is. Volume of solute divided by total volume of the solution into 100. Now, if you have X percentage V upon V or X percentage by volume, this would mean the volume of solute, it is X ml, when volume of solution is 100 ml, and hence the volume of solvent will be 100 minus X ml. Third, please write it me. Mass by volume percentage, W by V. In this, X percentage W by V means mass of solute is equal to X gram and the volume of solution it is equal to 100 ml. Say anything about the we cannot say anything about the mass of solvent or the volume of solvent because we don't have we cannot subtract grams from ml. If you have density, then we can find out, but not right now.
Yes, sir.
So these are the very elementary concentration terms. Now, these concentration generally going to be used in conversions of one concentration term to another. The important concentration term, that is molality. The important one is molality. Molality, molality. It is represented by small m, the lowercase m. What does it mean? It's number of moles of solute per kg of solvent. Per kg of solvent. Basically, molality, it will be equal to number of moles. We write it completely. Moles of solute divided by mass of solvent in kg. So the unit will be, so for moles we will write mole and kg inverse. Moles per kg. So moles, and we can write kg inverse, or we can say moles per kg, or we can just simply write molal, or we can simply write small m. All of these units are, you are going to see all of these units in questions. Now, once if you are writing an answer, you can also write all of these things, but I will always prefer this mole per kg. And in question also, if it is given small m, always rewrite it to moles per kg. It will give you an idea that in 1 kg of solvent, I have added 1 mole of solute. Mole of what? 1 mole of solute. So in short, we can write small m. It is equal to the number of moles of solute divided by the mass of solvent in kgs. The mass of solvent in kgs. Now we know that number of moles, it is equal to the given mass divided by the mass. So we can rewrite this as molality. It is equal to the given mass of solute divided by the molar mass of the solute multiplied by the mass of solvent in kg. Mass of solvent in kg. Now we can even further rewrite it. If I want the
Yes,
mass of
yes,
solvent in grams, then I can say that mass of, because most of
sir.
the time you will be given in grams, है ना? Divided by.
Sir,
If you want to ask something, हाँ tell me. Visible,
once
हाँ,
can you scroll it up, sir?
sure. एक बार कर ले पूरा, तो हम आपको टाइम देंगे. डोंट इफ यू आर राइटिंग ना, तो मतलब ऐसे लिखने की जरूरत नहीं है. फाइन सा, ऐसे जल्दी जल्दी
Yes,
लिखने की
sir.
जरूरत नहीं है. आई विल गिव यू कंप्लीट टाइम. ठीक है, वंस यू आर डन, मतलब वंस आई एम डन.
Okay, sir.
ओके.
Okay, sir. Thank you,
नाउ
sir.
we have mb, that is mass of the solute, multiplied by, if I take the mass of solvent in grams, I have to divide this by 1000, है ना? अगर ग्राम में दिया तो I have to divide this by 1000 in order to kg. Now if I have denominator of denominator, that means 1000 will go above. Make sense? Yes or no?
Yes, sir.
So this is molality. Now obviously I will can write all of these, but I would always suggest to use this particular formula. Calculate the moles separately and then divide by the mass of solvent in kg to keep things simple, है ना? And not memorize too many formulas. So you
Yes, sir.
can write this down. Let me know once you are done. Let me know once you're done writing. आराम से लिखिए.
Yes, sir. Done, sir.
Next, you can write mole fraction. We will do question once we write all the concentration terms. So, एक साथ we are going to do question.
Yes, sir.
Mole fraction. Mole fraction, it is represented by the small letter which is said called chi. है ना? chi. It's the Greek letter, which is something like
Yes, sir.
X and C. That is why it has something like chi. Now,
Yes.
what is mole fraction? Please write this with me. It is, आपने पढ़ा है ये सब क्या पहले?
पढ़ा है, sir.
तो पढ़ने आते हैं. Ratio of number of moles of a component to total number of moles. Total number of moles of all components of component. Fine. So let us suppose if I have a hypothetical solution in which I have 1, 2, 3, 4, 5, n components. है ना? So the mole fraction of ith component will be equal to number of moles of that component divided by, what I can write, divided by number of moles of the first component plus number of the second component plus number of moles of the third component plus dot till the number of moles of the nth component. Makes sense? Yes or no? Please tell me.
Yes, sir.
Now, for binary solution also, this is, we can say, this is what we can say it is for a hypothetical solution. Now, generic equation आपके पास है यहाँ पे, but for binary solution, or binary solution, I will have only chi A and chi B, right? So I can write the mole fraction of the solvent will be equal to number of moles of solvent divided by the number of moles of solvent plus number of moles of solute. And for the mole fraction of solute, I can say that it will be equal to number of moles of solute divided by the number of moles of solvent plus number of moles of solute. Now, an interesting, what I can say, relationship between chi A and chi B is that if you add the mole fraction, then this will be equal to number of moles of A divided by number of moles of A plus B plus number of moles of B upon number of moles of A plus number of moles of B. Now, both the LCMs are, I mean, the denominators are same, so it will be Na plus Nb, and in the numerator also will get Na plus Nb, and we can, whatever the Na plus Nb will be in the denominator, that same value will be in the numerator also, and hence you can get the mole fraction of A plus the mole fraction of B, that will be equal to. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Now, this is true for even if I have more than two components, the mole fraction of all components, the sum of mole fraction of all components is always equal to 1. So you can write sum of mole fraction of all components is equal to 1.
Done, sir.
The last concentration term that we'll be learning is molarity, which is represented as capital M. This is number of moles of number of number of moles of solute per liter of solution. Per liter of solution. So molarity, that is capital M, is equal to number of moles of solute, certain moles of solute divided by volume of solution in liters. So we can say that the unit will be moles per kg, or you can say molar, or you can say capital M. Similarly, number of moles of solute divided by the volume of solution in liters. And I can further write this as molarity is equal to the mass of solute multiplied by 1000. I hope you can understand. If you don't, then please let me know. Divided by the molar mass of the solute into the volume of solution in ml. Does the last one make sense? Yes or no?
Yes, sir. Done, sir.
So now let us start question. Right? So before question, just write few remarks. One molar. Okay, means 1 mole per kg means sorry, 1 mole per liter. 1 mole per liter means 1 mole of solute in 1 liter of solution. Okay. Similarly, if I have 2 molar, 2 molar or 2m, capital M, it would mean 2 mole of solute in 1 liter per liter, है ना? Moles, 2 moles per liter in 1 liter of solution. Similarly, if I have semi-molar, this would mean half mole of solute in 1 liter of solution. Similarly, if you have decimolar, this would mean 1 by 10 mole of solute in 1 liter of solution. Similarly, centimolar, or if you have millimolar, millimolar will be used in equilibrium mostly, millimolar, then this would mean 1 upon 1000 mole of solute in 1 liter of solution. Now, wherever I have written molar, you can write the same thing as molal also. I would just write 1 LAL or 1 small m. This would mean 1 mole per kg. This would mean 1 mole of solute in 1 kg of solvent. Similarly, 2 molal or 2 small m would mean 2 moles of solute in 1 kg of solvent. Semi-molal, it would mean 1 by 2 mole of solute in 1 kg of solvent. Decimolar and so on. Does it make sense? Yes or no, Shiza?
Yes, sir.
If you're done, I'm writing a question. You can write the question with me. Calculate the molarity of solution prepared by mixing 4 gram of NaOH in enough water to form 250 ml of solution. Are you trying?
Yes, sir.
Yeah.
So you reviewed 0.4 m.
Yep, correct. Very good.
Thank you, sir.
So basically, I will give both the methods. So if I go the long route, or what we can say is that if you want this route, then you can do this in brain also. No? If you don't remember the formula, then first of all, I will calculate the number of moles of solute, which will be equal to 4 grams. Molar mass of NaOH you have already written as 40 grams per mole. So this will be cancelled, and you will get 1 upon 10 mole. Now I will calculate the volume of solution, which is given as 250 ml. M means 10 to the power minus 3. Now it will be M ki jagah what I have written 10 to the power minus 3, and I have this in liters now. So basically it is going to be 250 divided by 1000. You can simplify a bit, and I will get this as 1 by 4. I will get this as 1 by 4 liters. Now I can say that molarity it is equal to number of moles, that is 1 upon 10 divided by the volume of solution, 1 upon 10 mole, and divided by the volume of solution in liter, that is equal to 1 upon 4 liter. And the 10 will go down, 4 will go up. I will get 4 upon 10 and in moles per liter, and this will be equal to 0.4 molar. Sorry, 0.4 molar. Or if you remember the formula, then you can directly write M molarity it is equal to 4 into 1000 divided by the molar mass, that is 40, multiplied by the molar mass, that is 250. So you can cancel some zeros like this, some 4 like this, and what else? 2s are, and this will be 5s are. So I will get this as 2 by 5, which will be equal to 4 by 10 if I multiply 2 on both the sides, and I will get 0.4 molar.
Yes, sir.
So no matter what method you use, have given the correct answer. Can I move
Sir,
forward?
I use the right side method, sir.
Right one, no? That's fine. Until
Yes.
if you remember that this is always the fastest one. If you have pen and paper, if you have pen and
Yes, sir.
paper and you remember the formula, always this one. If you are in, if you get confused, for example, then use the long route. There is no problem in that. Okay,
Yes, sir.
fine. Write another question. Calculate the molality of 40% aqueous NaOH solution.
Sir, can you explain it, sir?
Yeah, sure. No problem. Now you need to extract all the information that you can from the uh, or the question that is given. Chaliye, you will help me in that. Okay, fine. Tell me, what are the things that you can say from the question? No matter what they're asking, I don't want to know what they're asking. They have given us only this much information, right?
Yes, sir.
Or if you include the by mass part, then this much is the information that they have given. What are the things that you can expect? Even though it is very obvious, फिर भी हमको कुछ.
Sir, 100 grams of solution contains 40 grams of NaOH.
Very good. 100 grams of solution contains 40 grams of NaOH. That's all you need. From this, you can get the number of moles of NaOH. Yes or no?
Yes, sir.
It has to be. From 100 gram of solution, you can say in 100 gram, 40 gram is to NaOH.
60 gram
है
of
ना?
water.
Gram will be what water. है ना?
Yes, sir.
This is what I am
Yes, sir.
talking about. If I like all the information that you can extract. Now from 60 gram of water, you can convert this to kg. On this to kg, हो जाएगा अब.
Yes, sir. Sir, 16.667 molar.
How much you're saying? 50.
16.66
16.
molar.
Yeah,
Yes,
that
sir.
is correct. Very good. So molarity will be the mass of solute multiplied by 1000 divided by the molarity molar solute multiplied by the mass of solvent in grams. You can write no in this case. Okay. So mass of solute is 40 into 1000 divided by 40 into 60. So 100 upon 6 will be 16.666. So you can 7 moles per kg. If I
Yes,
say
sir.
for this same question, determine mole fraction of NaOH, हो जाएगा?
Yes, I'll try, sir.
You just need to calculate the number of moles.
Yes, sir. Sir, 0.23.
0.23.
23.
Just give me a second. Let me just calculate it.
0.2307, sir.
Okay. Correct. Very good. Correct. So mole fraction of NaOH will be number of moles of NaOH that is equal to 1 divided by 1 plus, you can say 60 upon 18, right?
Yes, sir.
So it will be something like this.
Yes, sir.
है ना? So 18 upon कितना हो जाएगा ये 78.
Yes.
So it will be equal to 2.0.2. If they ask a question something like this is a famous question, although it is not. I mean, I don't like this question because I will tell you the reason. But it is a famous question and it is a very what I can say common that each and every teacher will teach, and each and every calculate the molarity of textbook of chemistry will have this question of 1 liter of water. Although I don't like this question, see, if what is not given is you the density of water, so we know that density of water equal to 1 grams per ml, 1 grams per ml. Now
Yes,
we can
sir.
say that 1000 grams is in 1000 ml,
Yes, sir.
correct? Right. So we can say that 1000 gram in 1 liter, correct?
Yes, sir.
Now that means 1000 gram of water is there in 1 liter of water. I can calculate the number of moles of water that will be equal to 1000 upon 18, correct? So I can write this
Yes,
as
sir.
500 upon 9, yes or no?
Yes, sir.
Okay. तो आपको एक चीज हम बता देते हैं. फॉर एग्जाम्पल, if you have anything divided by 9, now for example, if you have 500 or 9, something like this number, and if you have only one non-zero digit divided by 9, आप इसको ना ऐसे लिख दीजिए 5 5 5 5 ऐसे कर दीजिए. Now
Yes.
after how many digits you will have decimal point? अब देखिए यहाँ पे कितना है, how many zeros?
2 zeros.
2 zeros. तो आगे से है ना, यहाँ से वो, यहाँ से एक और दो यहाँ पे लगा दीजिएगा. ठीक है. So
Yes,
for
sir.
example, if you have 50 upon 9, so this will be equal to 5.55555. If you have 5 upon 9, this will be equal to 0.55555. ठीक है.
Yes, sir.
You will start the from here. जैसे एक जीरो बढ़ा तो ये एक इधर. If you have 5,000 upon 9, then this will be what? 555. तीन जीरो है तो उतना 5 लिख दीजिए, 0.555. If you have
Yes, sir.
6,000 upon 9, इसका बताइए 6,000 upon 9 कितना जाएगा?
666.61.
हाँ, 666.6. ठीक है, 67 हो जाएगा
Yes.
इसका. फाइन. Now this is the number of moles. So the molarity will be equal to how many moles we have? 5.55 moles. In how many liters? 1 liter. So this will be equal to what? 55.55 moles in 1 liter.
Yes, sir.
Why I don't like this question? Because water is not a solution. Na? If something is not a solution, then why are we calculating the concentration for it,
Yes,
right?
sir.
Let me know if you're done.
Done, sir.
By the way, this information is rather useful. You can remember this. It will be used somewhere in equilibrium thermodynamics. Number of moles in 1 kg or 1 liter of H2O is equal to 55.55, yeah, 56 exactly. I mean, if I approximate it, 56 moles. Okay. Right. Another question.
Yes, sir.
Calculate the mole fraction of 2SO4. I've given the molar mass. It is 98 in 5 small m H2SO4 solution. You want to try it?
Yes, sir. Sir, is it 4.4?
4.4. Mhm.
Or sir, 0.9 sir, 0.9.
Huh?
0.9 sir.
0.9.
Yes sir.
Sure.
I don't know sir.
चलिए ठीक है देखते हैं जरा है ना. So what is 5 small m by the way? This
Sir,
would mean
5 molar
5
molar.
molar
Yes sir.
or mol. Small m is used for 5 moles per kg na.
Molarity. Yes sir.
Molality per kg na. So not moles per liter, molar, LAL, right?
Yes sir.
5 moles per kg. This would mean what? Would mean 5 mole of H2SO4 in 1 kg of water. Correct? Yes or no?
Yes sir.
So 5 moles, I have got the number of moles of solute that is equal to 5. And in 1 kg of water,
Water
this
sir.
value, number of moles of solvent will be equal to 55.56.
5 sir. Yes sir.
You got these values, yes or no?
Yes sir.
Okay. So mole fraction of the solute will be equal to 5 upon 55.5 plus 5. Correct? Yes or no?
Yes sir.
5 upon 60.5 makes sense.
Yes sir.
So this value you are getting as 0.9.
No sir, I did it wrong sir.
So what will be the value approximately?
Just a second sir. 12.1 sir.
How much?
1.1 sir.
Just give me a second. One point one you are saying.
12.1 sir.
अरे उल्टा डिवाइड कर दिया आपने देखिए जरा 5 अपॉन 60.5 है.
Yes sir.
फिर से
0.0826 sir.
0.0 एक कैलकुलेटर से कर रहे हैं क्या आप?
नहीं sir.
0.026. Now we can say that we can note this है ना, that for if the molality is m molal aqueous solution, if you have m molar aqueous solution, ठीक है, then
Yes sir.
the mole fraction of solute will be equal to whatever the value of m is divided by 55.5 plus m. Correct है, yes or no? सही हुआ ना? In the
Yes sir.
previous case, Done? Can I move on?
Yes, sir.
Right. More question. The density of 3 molar solution of NaCl is 1.25 grams per ml. Calculate the molality calculate the molality of solution. Please see. चलिए हमको जरा बताइए. If I have 3m, 3 capital M means 3 moles. Tell me per
Yes, sir.
what?
Okay. Liters.
Per liter है
Liter.
ना, capital M ना, so per liter. This would mean 3 moles of NaCl in 1000 ml of solution. करेक्ट है यहाँ तक? हाँ या ना बताएं.
Yes, sir.
चलिए नेक्स्ट थिंग प्लीज ध्यान सुनिएगा. ठीक है, ध्यान सुनिए. नाउ आई कैन से दैट 3 moles of NaCl will be equal to 3 into 58.5 grams of NaCl. करेक्ट है.
Yes, sir.
Volume of solution will be equal to 1000 ml of solution, right? So 1000 ml, right? Density is given as
Yes, sir.
1.25 grams per ml. I have volume, I have density. I have volume and I have
Density.
what? Density. I can calculate the mass of solution, right? Density it is equal to mass by volume. So mass will be equal to density into volume. क्या ख्याल है?
Yes, sir.
Let's do this. ये है, कभी कभी सही हो जाता है. See. So volume of solution will be equal to volume is how much? 1000 ml. So mass of solution will be 1000 ml multiplied by 1.25. This will be equal to 1250 grams. Now this mass of solution, it will have solute as well as solvent. Correct? Yes or no?
Yes, sir.
Solute is how much? Tell me. What is the solute? What is the mass of NaCl that we have here? देखिए जरा कहाँ पे. हाँ, tell me.
3 into 58.5, sir.
Yeah. Correct. 3 into 58.5, that will be equal to 175.5. So mass
Yes,
of
sir.
solvent will be 1250 minus 175.5. Correct? Because this is the mass of solution minus the mass of solvent, we will get mass of solvent. Make sense?
Yes, sir.
All of these values are in grams. So I will divide this by 1000 and I will get this in kg. क्या ख्याल है?
Yes, sir.
So I have got the moles, है ना? I have
Yes,
got
sir.
the moles and I have got the mass of solvent in kg. Now I can just divide them. क्या ख्याल है?
Yes, sir.
So I can say that molality small m will be equal to how many moles? 3 moles. Now this 1000 will go above when I divide it. I will write here 1000 as you will understand. Divide by 1250 multiplied by 1 multiplied divide minus 1250 minus 175.5. ठीक है. Now from what we
Yes,
can
sir.
do now, we can make a generic formula also. So Please see. Molality, it is equal to whatever the molarity is multiplied by 1000 divided by 1000 into D minus the molarity multiplied by the molar mass of the solute, because this 1250 is here because of 1.25, because of 1.25 into 1000. Now this 175
Yes.
is here because of 3 into 58.5. This 3 is same as the number of moles. Makes sense? Please tell me.
Yes, sir.
Okay. So now you can calculate this. This will be equal to um,
So 3000 by 95.5.
1074.5. देख लीजिए कितना 2.8
Yeah,
समथिंग
yes,
आना
sir.
चाहिए.
Yes, sir. Yes, sir. Yes, sir.
2.8 मोल. आपको अबैकस वगैरह आता है क्या?
नहीं सर.
तो और ये कैलकुलेट.
सर आप जब राइट साइड का फॉर्मूला लिख रहे थे मैं was calculating
अच्छा
it,
तो कम डिवाइड करता है.
sir. Yes, sir.
ठीक है. सो आई थिंक वी हैव डन एम्पल अमाउंट ऑफ क्वेश्चंस एंड काफी मिक्सचर भी है इसमें, है ना. हर तरीके से लाइक मोलालिटी काफी ज्यादा हम लोगों ने कर लिया. व्हाटएवर वी हैव डन ना, प्लीज ट्राई टू रीडू ऑल ऑफ दीस प्रॉब्लम्स एंड देन यू विल गेट होमवर्क आल्सो. ओके शिजा.
Yes,
अब
sir.
एक टॉपिक है जिसको आप लिख लीजिए, मोलारिटी
Yes.
मिक्सिंग. So suppose here we have a container. जब हालो भाई हम आपको नहीं कह रहे थे, मैं सिस्टम इज नॉट वर्किंग प्रॉपर्ली ना.
Yes.
क्या हो जाता है कभी कभी इसको. So suppose we have the molarity of this M1, the volume here we have V1, the molarity of this is M2, the volume is V2. Okay. Now, if I have N here, let us suppose I have N1 number of moles. How much moles? We have N1. The first solution,
Yes.
it has N1 moles, and this has N2 moles. When I'm going to mix it, then I will get a, suppose I will get a bigger container. Oh, I don't know what's happening with the system. Now, here we have V2. So the resultant volume will be, now this particular solution will have something MR, that is resultant molarity, and some resultant volume. So we know that VR will be equal to V1 plus V2 for sure, because if I have 100 ml and 200 ml, if you mix it, you will get 100 ml. But what about the molarity? Will the molarity will also add? No, the molarity is not going to add. Molarity add नहीं होगा. But क्या add हो सकता है? We can say
Yes,
that
sir.
N1 plus N2 can add. If I
Yes,
have
sir.
2 moles here and I have 3 moles here, I will be having 5 moles here. Does it make sense? Yes or no? Please tell me.
Yes, sir.
So I can say that the resultant number of moles will be equal to the N1 plus N2. Now we know that molarity, it is equal to number of moles by volume. So number of moles, please see number of moles, it will be equal to what? Molarity into volume. क्या ख्याल है?
Yes, sir.
So instead of N1, I can write M1V1. Instead of N2, I can write M2V2. Instead of NR, I can write MRVR.
Yes, sir.
Now I can write MR as M1V1 plus M2V2 divided by VR, and you can further write this as MR is equal to M1V1 plus M2V2 divided by V1 plus V2.
Yes, sir.
Let me know if you're done.
Done, sir.
Write one more, that is dilution formula. Now, what happens in dilution? Suppose we have a container and we add water to it. We add water in this container. Okay, add water, and this addition of water is known as dilution. Once you add water, then obviously the volume will increase. But if I have 2 moles initially, and I am not changing the number of moles, I'm just increasing the volume. Okay, I'm just increasing the volume. So here, if I have number of moles, let us suppose is NB, uh, NB. Here also it will be equal to NB. And let's suppose the molarity was M1 and V1 here. The molarity is M2 and V2 here. So I can say that since the number of moles is equal in the first and the second case, before dilution and after dilution, so I can say that M1 V1 is equal to M2 V2. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Right? Why? Because number of moles before dilution will be equal to number of moles after dilution. Now I can say
Yes, sir.
that M2, the molarity after dilution, M2 will be equal to M1 V1 upon V2. Now what will be V2 actually? V2 will be V1 plus added volume of water or whatever solvent you are using. Generally, it is going to be water.
Yes, sir.
Please copy this down. Let me know if you're done.